All right, folks, for the next couple of days, we are going to be working with something called an inverse function. So we'll start out today with just a few facts about an inverse function. Now, here's the first thing you need to know. An inverse function reverses the order of the inputs, which we know are the x's, and the outputs, which we know are the y's, for a function. Now, all of that is just a fancy way to say that the inverse of a function switches x and y. So an inverse function is going to reverse the order of the inputs and the outputs for any given function. And like I said, that's just a fancy way to say that the inverse is going to switch x and y. Now, here's something else that we're going to need to know about this, and this has to do with the way we write things. For a function f of x, the inverse is written as f with a -1 exponent of x. So f of x is the way we write the function, and then this is how we write the inverse of that function. The -1 is what tells you that it's the inverse. Now, the important thing for you to know is that when you see that f -1 of x, that is read f inverse of x. F inverse of x. So again, f of x represents the original function, and the f -1 of x, which we read as f inverse of x, that is what represents the inverse. So let's start out nice and easy with this and give you kind of an example to look at here. One of the things we've done throughout this unit as we've worked with functions is we've talked about function tables, input-output tables that show us how that function is connecting x's to y's. So let's say I have a function f of x, and in that function it takes a 2 and pairs it with a 0. It takes a 3 and pairs it with a 1. It takes a 4 and pairs it with a 2. And then finally it takes a 5 and pairs it with a 3. So this is my first function table. Notice it is for the function f of x. So this is a function that connects 2 to 0, 3 to 1, 4 to 2, and 5 to 3. If I wanted to do the inverse function table, so f inverse of x, then using what we have said so far here, all this inverse is going to do is switch the x's and the y's. It's going to reverse the inputs and the outputs. So when the input was 2, the output was 0 for the function. That means for the inverse, if 0 is the input, then 2 is going to be the output. That's all the inverse will do, is just take this input and this output and reverse them. So instead of 2, 0, we'll get 0, 2. This function took 3, an input of 3, and produced an output of 1. So that means the inverse would take an input of 1 and output of 3. It's just going to reverse those. So the function itself took an input of 4 and output of 2. So the inverse will input a 2 and output a 4. And then finally, the function input 5, output 3. That means the inverse will input 3 and output 5. So this is literally all an inverse does. It simply takes those inputs and outputs and reverses them. The input becomes the output and vice versa. Now, one of the things that you know you can do, and you've done this before, is you can take a table and figure out what the rule is, what the function rule is, especially if it's something kind of simple. So I want you to notice here, when the input was 2, the output was 0, 3, 1, 4, 2, 5, 3. So when you look at that, what does it appear this function does to the x value? How did it take 2 and produce this 0? How did it take 3 and produce this 1? How did it take 4 and produce this 2, and so on down the line? Well, it kind of appears to me that whatever this x is, to get the output, this function looks like it's subtracting 2. So if I wanted to write the rule for this function, I could write that f of x, which we know is y, f of x, which we know is y, is the result of taking the x and subtracting 2. So if I did 2 minus 2, I would definitely get 0. If I did 3 minus 2, I would definitely get 1. If I did 4 minus 2, I would get 2. If I did 5 minus 2, I would get 3. So this is definitely the rule that's going on in that function table. So in f of x, in the original function, it takes whatever the x is, whatever the input is, and it subtracts 2 in order to get that output. Now let's come over here and let's look at f inverse of x and think about its rule. What's happening in this table? All right, well, when this inputs a 0, it outputs a 2. 1 produces a 3, 2 produces a 4, and so on. So it looks like in this one that I take the x and I add 2. So I think this function's rule for the inverse must be x plus 2. So if I did 0 plus 2, I'd get the correct output. If I did 1 plus 2, I'd get the correct output. If I did 2 plus 2, correct output. And then finally 3 plus 2, correct output. Now I want to point out something about these two rules. I want you to notice that f of x subtracts 2 from x, and that f inverse of x adds 2 to x. I want you to notice that these inverse functions do the opposite of each other. One is subtracting 2 from x, the other is adding 2 to x. And that's something that we ought to see as we look at these inverses. They ought to undo each other. They ought to do the opposite of each other. Let's, real quickly here, look at another example. Let's say that for the function f of x, that it works in this way. When you input a 1, you output a 2. When you input a 2, you output a 4. When you input a 3, you output a 6. And finally, when you input a 4, you output an 8. So if I look at this and I think about what I see happening here, how are they determining that y value? 1 goes to 2, 2 goes to 4, 3 goes to 6, 4 goes to 8. It looks like the x value is doubling each time. 2 times 1 is 2. 2 times 2 is 4. 2 times 3 is 6. 2 times 4 is 8. So overall in this function, I can find f of x, or y, by doubling the x value, by multiplying it by 2. So again here, let's do kind of the same thing. Let's make the inverse table. So f inverse of x is going to take these input-output pairs in the functions table and reverse them. So instead of 1, 2, I'll have 2, 1. Instead of 2, 4, I'll have 4, 2. Instead of 3, 6, I'll have 6, 3. And instead of 4, 8, I'll have 8, 4. Now, let's look at a rule for f inverse of x. 2 goes to 1, 4 goes to 2, 6 goes to 3, 8 goes to 4. It appears that in this function table, we're taking half of whatever x is in order to figure out this y value. And when we take half of something, we divide it by 2. So 2 divided by 2 would give me 1. 4 divided by 2 would give me 2. 6 divided by 2 would give me 3. 8 divided by 2 would give me 4. So I'm going to say over here that f inverse of x has the rule x divided by 2. And again here, I want you to notice the connection between these rules. F of x tells me to take 2 and multiply it by x. So it's multiplying x by 2. F inverse of x tells me to take x and divide it by 2. And notice again there how multiplying by 2 and dividing by 2 are opposites of one another. So that's a characteristic that inverse functions ought to have. They ought to do opposite operations. So if the original function is adding, the inverse should subtract. If the original function is multiplying, the inverse should divide. But always when you're thinking of inverses, keep this concept in mind, that an inverse is going to reverse input-output pairs. It's going to switch the x's and the y's. So now, let's talk about what you're going to be doing today. Now that we have a little bit of introductory information out of the way, you are going to be finding the inverse of a function algebraically. So you're going to find the inverse of a function algebraically. So you're going to use algebra to do this. Now, this is a 4-step process. So I'm going to write these 4 steps down first. And I would suggest that you definitely take a moment to pause the video when all 4 steps are up and write them down yourself. And then I will take you through a few examples so you can see how we're going to use this. All right, so to find the inverse of a function algebraically, the first thing you are going to do is you're going to look at the function and you're going to replace f of x in that function with y. We know that f of x and y are 2 different ways to say the same thing, so we're just going to make things simpler by replacing the f of x in the function with y. Now, the second step is to do exactly what an inverse wants you to do. An inverse switches the x and the y. It reverses the input and the output. So what you're going to do for step 2 is you are going to switch the x and y variables. And again, you're going to do that because this is what an inverse's job is. An inverse's job is to switch those 2 variables, to switch the input and the output. Now, that will give you a new equation. And what you will do is you will solve your resulting equation for y. So you'll get y by itself, in other words. Because that's how we want it to be in a function. Functions always start out with f of x equals, y equals. So we want to take it back to that format. Solve your resulting equation for y, get that y by itself. And then what you are going to do as your last step is to write your answer using your function notation. And your function notation, of course, is that f of x notation. So what you're going to do here is you're going to use f inverse of x to write your answer. So if they give you an equation, if they give you a function equation, and they say to you, find the inverse of this function, these are the steps you need to go through. Replace the f of x in the function with y, so that you can then do what an inverse wants you to do and switch that x and that y variable. Once you've done that, then solve the resulting equation for y, get that y by itself again, and then you'll change it back over to function notation. And when you change it over, you'll use the inverse function notation, f inverse of x, to say, hey, this is not the original function anymore, this is now the inverse. So again, I would pause right here if I were you and write down these 4 steps so that you can kind of follow along with those in the examples I'm getting ready to do. So, in the examples I'm getting ready to do, I am going to ask you to find f inverse of x. So, just so we're sure we understand what this is saying to find the inverse of f of x. So that's what I'm asking you to find. All right. So we're going to start out with functions that are pretty easy and then work our way up. So the first function I'm going to give you is f of x is equal to x minus 7. So in this function, when you input an x, it will subtract 7 from that x to give you your output. All right, now remember your steps. Step 1 is to replace f of x with y. So I'm going to come up here to this equation, and where I see this f of x, I'm going to replace it with y. So it will now say y is equal to x minus 7. Step 2 is to switch the x and the y variables. So the output and the input are going to swap places. So when they do, it will say x equals y minus 7. So that is my new equation. That is my resulting equation, the result of switching that x and that y. All right, now what I'm going to do is I'm going to take this equation and I'm going to solve it for y, which means I want to get this y by itself. Now look at what this problem says it's doing. It's taking that y and it's subtracting 7 from it. So if I want to solve, I'll have to do the opposite. So I'm going to add 7 to undo that subtracting 7. And if I do it to one side, I know I have to do it to the other. So this minus 7 and plus 7 are going to cancel each other out. So I have x plus 7 is equal to y. So here was step 1. I replaced f of x with y. Here was step 2. I switched the x and y variables and got this. And then here's step 3. I do what it takes to get y by itself. So when I see y minus 7, I know I have to do the opposite and add 7 to both sides to get that y alone. All right, now I want you to look at what we have. We have x plus 7 is equal to y. And you all know that we could flip-flop those two sides and write that as y equals x plus 7. The step 4 I told you was to rewrite this thing in function notation. So we're going to take this y and replace it with f inverse of x, because that's what we have now, is the inverse. F inverse of x is equal to x plus 7. So, going back to what we did a few minutes ago with those tables, I want you to think about what we have here. Look at these two rules. F of x had the rule x minus 7, so it takes x and subtracts 7. f inverse of x has the rule x plus 7, so it takes x and adds 7. So I want you to notice again how this fits in exactly with what we saw happening in those tables. In this rule we subtract 7, in this rule we add 7. Those are opposites of one another, just as they should be. All right, so take it one step at a time. Go through those 4 steps with any function rule that they give you. All right, let's do this one. Let's do f of x is equal to 8x. So there's my original function. Now what I'm going to do is figure out the inverse for that function. All right, so let's start at step 1. Step 1 is to replace f of x with y. So I'm going to replace this f of x with a y and rewrite this thing as y is equal to 8x. So there's step 1. Step 2 is to switch the x and the y variables. So the x and y variables are going to switch places, so that will give me x equals 8y. All right, for step 3, I need to solve for y. So I want this y to be by itself. In order to get y by itself, I'm going to have to get rid of this 8. It's 8 times y, so it's being multiplied by 8 right now, so I'm going to do the opposite and divide by 8. 8 divided by 8 we know is 1, so that cancels those out over here. So I end up with x divided by 8 is equal to y. So there's step 3, get that y by itself. And we know, of course, that we can write this as y equals x divided by 8, that's the same difference, switching those two sides. And then the fourth and final step is to put that back in function notation. So f inverse of x is x divided by 8. So this is the inverse. This is what you were after. But I want to point out again here, that in f of x, you do 8 times x. And in f inverse of x, you do x divided by 8. So one multiplies by 8, the other divides by 8, which again, opposites. So that's what we're looking for. All right, so next function rule. F of x is equal to 2x plus 6. So in this function's rule, we do 2 times whatever x is, and then we add 6. All right, so let's find the inverse. To find the inverse, the first step is to take the f of x and replace it with y. So this is going to be y equals 2x plus 6. Step 2 is to reverse the x and the y variables, switch the x and the y variables. So this is going to be x equals 2y plus 6. Step 3 is to solve for y. So I want you to look what we have here. We have 2 times y plus 6. The first thing we'll do is get rid of this plus 6. So we'll do minus 6 on each side first. That'll give us x minus 6 is equal to 2y. The plus 6 and the minus 6 will zero each other out. I want you to notice that y is still not by itself. We have 2 times y right now, so the next step will be to divide by 2. 2 divided by 2 is 1. So now that y is all alone. Now, I want you to take a look at what we have here. We have x minus 6 all divided by 2. What that means is we have to divide everything on the top by 2. So you'll have to do x divided by 2, which you can't do. And then you'll have to do 6 divided by 2, which you can do, which will be 3. So you'll get x divided by 2 minus 3. Equals y for your inverse. So your inverse will be f inverse of x, writing it in function notation, this is step 4, x divided by 2 minus 3. And you know, I've taken the time on all of these that we've done so far to show you how these are opposites. Now, you know, you can definitely see here that this one multiplies by 2 and this one divides by 2. But this one is adding 6. So shouldn't this one be subtracting 6? Well, what I need for you to do is go back to what we had right here. X divided by 2 minus 3 we got from x minus 6 divided by 2, right? So it would be an alternate version of this function rule. So notice the function multiplied by 2. This one divides by 2. Notice the function added 6. This one subtracts 6. So it's a little easier to see those opposites if we compare 2x plus 6 to x minus 6 over 2. This is just simplified. So after you simplify, sometimes you lose that ability to be able to see the opposites, but they are there. They are there. So notice every single time how I'm going through those same 4 steps. I'm replacing the f of x with y. Then I switch the x and the y because that's what an inverse always does. Then I solve for y. I get y by itself again. And then I can change it back to function notation. But when I change it back, I use my inverse notation instead of the original function. Because I want to know, one is the original and one is the inverse. Now, just because I know how much we love fractions, I want to show you just a couple of problems that involve fractions. So here's my original function. F of x is equal to 1/2 times x plus 3. So I'm going to take half of x and then add 3 to get my output. If I want to find the inverse, first I take f of x and I replace it with y. So I get y equals 1/2 x plus 3. Step 2, let x and y switch. So that'll make it x equals 1/2 y plus 3. Now I'm going to get y by itself again. Okay, so I have 1/2 times y plus 3. So to get y by itself, one thing I'll have to do is subtract 3 on both sides. 3 minus 3 zeroes out. So I have x minus 3 is equal to 1/2 y. Now, when you see 1/2 times y, you could here divide both sides by 1/2. You could certainly do that. But there's a better way, a way that's preferable. So when you need to get rid of a fraction like 1/2, a good way to do that is to multiply by its reciprocal. So when you need to get rid of a fraction like 1/2, a good way to do it is to multiply by its reciprocal. And you all will remember that to get the reciprocal of something, you simply flip it over. You invert it. So the reciprocal for 1/2 is going to be 2. So we're going to multiply here by 2, which is like 2 over 1. And then we would have to multiply by 2 over here. And I want you to notice something. When I multiply by 2 over here, I multiply the entire side by 2. So here's what we get. We get 2 times x minus 3 is equal to y. And if you wanted to, you could distribute. So this would be 2x minus 6 is equal to y. And I would take either one of those answers. Either of those answers. So now let's put him back in function notation. The inverse of this function could either be 2 times x minus 3, or if I want, 2x minus 6. I think probably if you go with the first version up here, it's a little easier to see those opposites going on. before you simplified. Taking half of something is like dividing by 2. So notice this multiplies by 2. So that's definitely an opposite. And then notice that this adds 3, this subtracts 3. So those are definitely opposites. So a little easier to see the opposites before you actually simplify. But either of these answers would be perfectly fine with me, whichever you would prefer. But what I wanted to show you on this one is that when it's time to get rid of this fraction, flip it upside down and multiply. That is the best way to get rid of a fraction in algebra problems. All right, let's do one last one so we can kind of see that again. Let's find the inverse for f of x equals 3/4 x minus 1. All right, to find the inverse, first we are going to replace f of x with y. That will make it y equals 3/4 x minus 1. For step 2, we're going to switch x and y, which will make it x equals 3/4 y minus 1. And now we're going to do what it takes to get this y by itself. So if you have 3/4 y minus 1, first you'll add 1 to both sides, which will give you x plus 1 is equal to 3/4 y. And now, to get rid of that 3/4, this is where I would multiply by the reciprocal. So to get rid of 3/4, I'm going to multiply by 4/3. When you multiply by 4/3 on this side, you have to multiply all by 4/3, so I'm going to put that in parentheses. So I get 4/3 x plus, or no, excuse me, 4/3, when I distribute, I get 4/3 x, 4/3 times x, plus 4/3 is equal to y. So I got this from distributing 4/3 to both things inside the parentheses. Now, final step is always just to write it in function notation. You'll always start with f inverse of x. Now again here, there would be two ways I would take this answer. I would take the unsimplified version. So you could do 4/3 times x plus 1 in parentheses. Or the simplified version where you distribute it. And again, I don't really care which one of those you give me as long as you get one of them. All right, so today and tomorrow, this is what you're going to work on. You're going to work on finding the inverse of a function algebraically. An inverse always wants you to switch the x and the y, to reverse the inputs and the outputs. So use those 4 steps, take one thing at a time, and definitely, if you have questions, let me know. Contact me. This is also a good time. This is your last week of virtual learning for most of you. Some of you I know are going to stay virtual from here on out. But for those of you who know you're headed back to class in person a couple days a week, now is a good time to tie up loose ends and get things finished up and turned in. Because you definitely do not want to come back into class behind and feeling like you're having to scramble to catch up. So I would recommend that you really take some time this week if you are behind on assignments to kind of get those caught up, get things squared away, so that when you return to class next week, either Monday and Tuesday or Thursday and Friday, you're ready to go.